NASA's James Webb Telescope hit by a space rock. One of the large mirrors driving the segment was hit by a larger than expected micrometeorite than engineers on Earth could test. While estimates are still ongoing, the telescope still appears to be functioning reasonably well. But the collision had negligible detectable effects in the data, NASA said in a statement. The object hit one of the mirror halves, allowing the telescope to work anywhere between May 23 and 25, the space agency said. NASA said the telescope was designed to withstand such an impact even if the piece of a rock was larger than expected. During the construction process, the researchers used a combination of simulations and actual collisions with mirror pieces to see how the telescope could withstand the impact of particles flying at breakneck speeds in space. We have always known the Webb must withstand a space environment that includes harsh ultraviolet light and charged particles from the sun, cosmic rays, and exotic sources in the galaxy, and accidental micrometeorite impacts in our solar system, said Paul Geithner, Associate Technical Director. We designed and built Webb with productivity margins, optical, thermal, electrical, mechanical, to ensure it can continue to fulfill its ambitious scientific missions even after many years in space. Space telescopes are also capable of dealing with collisions by moving their mirrors to correct problems with certain segments. It had already been relocated to deal with the collision and needed further adjustments. The telescope can also move through space on its own, allowing engineers to relocate the more sensitive parts of known meteor showers. However, the particles hitting the telescope were not part of the shower it is so famous for, and pending further investigation, NASA believes it was inevitable. However, over time, the telescope will inevitably be hit by harder objects in space, thus degrading its performance. The process is awaited, and NASA only hopes that the telescope's performance will be high enough even if it declines to be useful for years to come. With the Webb mirror in space, we anticipate that accidental micrometeorological shocks will elegantly degrade the telescope's performance over time, said Lee Feinberg, Elements Manager for NASA's Webb Telescope. Since launch, we have had 4 smaller measurable meteorological shocks that were in line with expectations, and the most recent one larger than our projected deterioration. We will use this flight data to update our analysis of performance over time and develop an operational approach to ensure we maximize the performance of Webb's images as much as possible for years to come. Thanks.